Namaste students. So today we'll do the next topic of the chapter real numbers, that is decimal form of rational numbers. So before going to decimal form of rational numbers, let us recall what is a rational number. So we know the number which can be expressed in the form p by q, where p and q are integers and q will not be equal to 0, are known as rational numbers. So the decimal form of rational numbers. So in two decimal expansion you will get, the first decimal is your terminating decimal numbers and the second is non-terminating and repeating decimals. So any rational numbers, to convert it to decimal expansion, it will terminate. In what case it will terminate? So we'll do some examples. So let us take an example. Suppose (11 by 2 cube into 3). So we need to convert this rational number. This is a rational number. So this rational number, will it be terminating decimal or non-terminating and repeating decimal? We need to identify without actual division. We need to identify that this rational number will be terminating decimal or non-terminating and repeating decimal. For that, a simple thing that you need to know, that if it is a rational number, it will be in the form p by q. In this case, your 11 is your p and 2 to the power 3 into 3 is your q. So any rational number, to identify that this rational number decimal expansion will be terminating. So the hint that you should know, that your q, which is the denominator, q should be in the form 2 to the power m into 5 to the power n. Always remember, to identify this rational number will be the decimal expansion. The decimal expansion of this rational number will be terminating or non-terminating. Okay. To be a terminating decimal, the q should be in the form 2 to the power m into 5 to the power n. So in this case, for c 2 to the power 3, yes, we got 2 to the power m, but will there any 5 power of 5? No, we got here 3. So if you think this 3 and 11, will it cancel or not? No, it's not cancelling here. So as q, as in the rational number, the denominator q is not in the form a to the power m into 5 to the power n. So we can say that the decimal expansion will be non-terminating and repeating decimal. Okay. So since the denominator 2 to the power 3 into 3 is not of the form 2 to the power m into 5 to the power n. So the decimal expansion is non-terminating and repeating decimal. So to make our concept more clear, so let me take one more question. Let the second question be, (23 by 2 to the power 3 into 5 to the power 2). So 23 by 2 to the power 3 into 5 to the power 2. So in this Q is in the form of 2 to the power m into 5 to the power n. So in this case, this rational number will be the decimal expansion of this rational number will be terminating. Why terminating? Because the Q is in the form 2 to the power m into 5 to the power n. So we can write the denominator the denominator 2 to the power 3 into 5 to the power 2 is of the form 2 to the power m into 5 to the power n. So the decimal expansion is terminating. So this decimal expansion is terminating. So just take one more example. (77 by 210). So at first we will make this rational number in standard form. So how to make the rational number in standard form? By making the numbers in simplest form. That means by cancellation. So 77 and 210. Both the numbers by 7 we can cancel. So let me cancel. 7 11s are 77 and 7 3s are 21 0. So I got 11 by 30. Okay. So 11 by 30. Now I will find out the factors of 30. So factors of 30. So 2 15, then 3 5. So I can write 11 by 2 into 3 into 5. So what are the powers here? 1, 1 and 1. So the denominator in this case, you got 2 into 3 into 5. So this is not in the form of 2 to the power m into 5 to the power n. So this 2 into 3 into 5 is not in the form of 2 to the power m and 5 to the power m, because 3 is an additional number here. It should be only 2 and 5 as we got. The denominator (2 into 3 into 5) is not of the form 2 to the power m into 5 to the power n. So the decimal expansion is non-terminating and repeating decimal. So next, one more question let us do. (19/3125). So at first we'll see that this rational number is in the standard form or not. Yes, this is in the standard form. We can't cancel anymore. So this is in the simplest form, in the standard form. So we'll find out the factors of 3125. So with 2 we can cancel. Yes, with 2 if we do, we can directly do it 5, I think. Okay, 5. 5 6 are 30. So 30, 5 2s are 10, 5 5s are 25. 5 5 1s are 5, 5 2s are 10, 5 5s are 25. 5 2s are 10, 5 5s are 25. 5 5s are 25. So I can write here 19 by 1 2 3 4 5, 5 to the power 5. So if the denominator we got power of 5, if we got power of 5 or power of 2, we can multiply 2 power of 2. To match with the powers, I can write 2 to the power 5. If I am writing denominator, in the denominator 2 to the power 5, I can write with numerator also 2 to the power 5. So we got that the denominator is in the form 2 to the power m into 5 to the power n. So I can conclude the denominator (3125) can be expressed in the form 2 to the power m into 5 to the power n. So the decimal expansion is terminating. So the decimal expansion is in terminating. Next means one more question. 171 by 800. So 171 by 800. Similarly, I'll find out the factors of 800. 2 400, 2 200, 200, 250, 225, 5 to the power 5 and 5. So I can write 171 by 1 2 3 4 5, 2 to the power 5 into 5 to the power 2. So we got in the form 2 to the power m and 5 to the power n, isn't it? So the denominator 800 can be expressed in the form 2 to the power m into 5 to the power n. So the decimal expansion is terminating. Now the next question, after how many places will the decimal expansion of the following number terminate? After how many places will the decimal expansion of the following number terminate? So let me write a question. Suppose 69 by 60. Without actual calculation, we need to find out that after how many decimal places this will terminate. For that, I will find at first this rational number has to be written in standard form. So 3 to the 6, 3 to the 9, 3 to the 6, 0. So the standard form is 23 by 20. So 20, I'll find out the factors of 20, 2, 10, 2, 5. So I can write here 23 by 2 to the power 2 into 5. So the power of 5 is 1. So little bit careful in this case. A little small hint will give you the correct answer. So as you need to focus in Q. So it is in the form 2 to the power m into 5 to the power n. So this will be a terminating decimal expansion that we know from the above questions. So this will be a terminating decimal expansion we know. But after how many places? Decimal expansion will terminate? So we'll find out the largest exponent of this both. Which is the largest exponent of the denominator? So the largest exponent of the denominator is 2. The largest exponent of the denominator is 2. That means this rational number will terminate after 2 decimal place. Okay. As we can conclude as the largest exponent of the denominator is 2. As the largest exponent of the denominator is 2. The decimal expansion will terminate after 2 places, after 2 decimal place. So that will be how to find out the decimal place. So as we have concluded here that this rational number will terminate after 2 decimal place. So if we are asked to find out, what we will do? Let's see here. To proceed with that, we will make the power same. So 23 by 2 to the power 2 into 5 into 5. One more 5 I have multiplied. So I will multiply it with both numerator and denominator. Now I can write it as 23 into 5. How much I will get? 5 is 15. 1 carry 10. That means 1, 1, 5. And this I can write 2 to the power 2 into 5 to the power 2. So as we know that this will terminate after 2 decimal place, so I can write directly 1.15. 2 decimal place 1.15. 15. So this is the answer. So let me do one more question to make it more clear. Let me take one more question. Suppose 47 by into 5 to the power 2. So what is the largest exponent here? 3. So the largest exponent is 3. So we can say that a decimal expansion will terminate after 3 decimal place. But how to solve? So largest exponent is 3. So one more 5 has to be multiplied here. So 47 by 2 to the power 3 into 5 to the power 2 into 5 into 5. This is additional, so we need to multiply both numerator and denominator. Now I will multiply 47 into 5. 35, 20, 23. So 235 by, you can write 2 to the power 3 into 5 to the power 3. So 3 is the largest exponent, so it will expand after 3 decimal place. So 1, 2, 3. Before that I'll put a decimal sign. So 0.235. So how we got it? As the largest exponent of the denominator, in this case the largest exponent in the denominator is 3. So the decimal expansion will terminate after 3 decimal places. Let me take one more question. 91 by 1250. Our first work is to make the rational number standard. At first we'll see, can we make the rational number standard, or it is already given in standard form. 91 and 1250, already this number in standard form, so we will not be able to cancel this two number and no common numbers are there. So after that we'll find out the factors of 1250. 1250. With 2 I can cancel. With 2 if I cancel, what I will write? 2 times are 10. 2 7s are 14. 2 5s are 10. 2 6s are 12. I can write 2 6s are 12. 2 2s are 4. 2 5s are 10. 5 1s are 5. 5 2s are 10. 5 5s are 25. 5 2s are 10. 5 5s are 25. 5 5s are 25. So I can write 91 by 2 into 5 to the power 4. So which is the largest exponent here? Denominator 4. That means this number will terminate after 4 decimal place. But we need to make the power same, right? So there are 4 5s are here and 1 2. That means 3 more 2s has to be multiplied. That means I told this 91 2 into 2 to the power 3 into 5 to the power 4. 3 and 1 will become 4. So 91, as I have multiplied 2 to the power 3 denominator, I need to multiply it in numerator also. So into 2 to the power 3, 2 2s are 4, 4 2s are 8 by 2 to the power 4 into 5 to the power 4. So by multiplying 91 into 8, 91 into 8, 72, 7 to 8 by 2 to the power 4 into 5 to the power 4. As this number has the largest exponent as 4, so that means this number will terminate after 4 decimal place. So as the largest exponent of the denominator is 4, the decimal expansion will terminate after 4 decimal places. So if it has 4 decimal place, 1, 2, 3, one more 0 will be added. So 0.0728.